Hi everybody! Today we're going to finish chapter 9.1. So this is 9.1 part 2, and we're going to finish our properties of radicals by adding and subtracting and rationalizing. So hopefully at some point you learned that the only things you can ever add and subtract are like terms. And so for adding and subtracting radicals, we are just going to combine like terms. Now for a radical, like terms mean the same index and the same radicand. So a quick anatomy lesson of a radical. So that is called a radical sign. There's a tiny little number here that is called the index. If you do not see a number there, that number is a 2. So a square root has an invisible 2 right there. And the number underneath is called the radicand. So for instance, a very simple example would be like square root of 5 plus the square root of 5. That happens to be 2 square root of 5, like I have 2 of them. So that those both have the same radicand. They both have a 5 there, and they both have the same index. So when there's nothing there, there's an invisible 2. So if I want to actually give you an index, you can see like the cube root of 7, let's say plus 5 cube roots of 7 is going to give you a grand total of 6 cube roots of 7, because there was 1 here. 1 plus 5 is going to give you 6 of them. It's very similar to just adding and subtracting variables. Like 1x plus 5x would be 6x. Okay. All right, so let's look at some more complicated examples though. So in really all the problems you're going to do, they're always going to have the same index, like they're both square roots, but they're not always going to have the same radicand. So you'll notice here we have an 8 and a 2. You cannot, this is not 6 square root of 8 or 10 or I don't even know. Okay, you may not add these as is because they do not have the same radicand. But we learned in the first part of 9.1 that you can simplify radicals. You use your perfect square numbers, which are like, well, 1 that we don't use, but 4, 9, 16, 25, 36, 49. Those are your perfect square numbers. And which one of those goes into 8? Well, it is 4. So the square root of 8 splits apart into the square root of 4 and the square root of 2. The square root of 4 becomes a 2, but you still had that 3 out front, and you're multiplying. So this actually becomes 6 square root of 2, because that's your square root of 2, plus 3 square root of 2. Now you add them together. Once they have the same radical, or the same radicand, I should say. Once they have the same radicand, then you can add them together, and this is going to be 9 square root of 2. So the next two, and hopefully you noticed we're kind of doing our extra practice backwards here. I thought these were the easier ones. We'd get them out of the way. The next two each have 3 terms, so you're just going to simplify all 3 terms, just a term at a time. So for 23, we're going to start with the square root of 18, and which one of the numbers over on the right go into 18? 9 does. So this is the square root of 9 and the square root of 2. The square root of 9 is a 3, but remember there's a 2 out front. So this is going to be 6 square root of 2. And then we're going to move on to the square root of 20, and which one of those numbers goes into 20? It's 4, so we got the square root of 4 and the square root of 5. Square root of 4 is 2, but you got to remember that 2 out front, and then there's a minus sign. So we're going to do a minus. 2 times 2 is 4. This one is the square root of 5. And then we're going to do the square root of 5 there on the end, which none of those numbers go into square root of 5, so just minus 2 square root of 5. So sometimes all 3 terms can be made into like terms, and sometimes they can't, and that's okay. In this case, only 2 of the terms are like terms. So the 6 square root of 2 is just going to hang out front, And then I have a negative 4 square root of 5 and a negative 2 square root of 5, which together make a negative 6 square root of 5, and that's your answer. Those cannot be combined. You can't combine a square root of 2 and a square root of 5. All right, I'd really like you to pause the video and see how far you can get on 24 before you need to press play. So try number 24. All right, so hopefully you broke the square root of 12 down into 4 and 3. The 4 becomes a 2 because it's under the square root, and you had that 3 out front, so you got 6 square root of 3. Then the 18 broke down into 9 and 2. Square root of 9 is 3, and you had that 3 out front, so you got a 9 square root of 2. And the square root of 27 broke down into 9 and 3. The square root of 9 is 3. You had a 2 out front, so it's 6 square root of 3. Your 2 square root of 3s are like terms. It has nothing to do with the 6's out front. It has everything to do with those square roots of 3. So if I have 6 square roots of 3 and I add another 6 square roots of 3 to it, I have a total of 12 square roots of 3 and 9 square roots of 2. You might ask, what's the order preference on does the square root of 3 come first or the square root of 2 come first? That one does not matter. All right, let's talk about multiplying radicals. So the first thing you're going to do is you're going to multiply the coefficients out front, and then you're going to multiply the radicands. Okay, so let's see what that looks like. In example 25 here, you have 2 square root of 5 times the group square root of 6 times plus 2. So when you distribute, you're going to take 2 times 1, because the coefficient right here would be 1. So 2 times 1 is 2. And then you're going to do the square root of 5 times the square root of 6, which is going to be the square root of 30. That's your multiplying of your radicands. Plus, okay, then you're going to multiply 2 times 2, which would be 4. And then you have a square root of 5 with no square root, and it's just going to be the square root of 5. So you multiplied your coefficients and you multiplied your radicands. Now, you need to continue, and if things simplify, you need to simplify. So looking at your perfect squared numbers, do any of those numbers go into 30? They do not, so then you're done. Like, that's your answer. All right, so that one was just distributing is all we did there. I promise you that's spelled right. Okay, on the second one, you're going to FOIL. My stylus likes to link letters. All right, FOIL. So we're going to do first. So square root of 7 times square root of 7. So their coefficients are just 1. So square root of 7 times square root of 7 is the square root of 49. Or do you happen to know the square root of 49? It is just 7. So you can jump straight there if you want to. Square root of 7 times square root of 3 is going to be the square root of 21. Negative square root of 3 times the square root of 7 is a negative square root of 21. And then for last, a negative square root of 3 and a negative square root of 3 is a negative square root of 9, which is a negative 3. Okay, notice that your two middle ones cancel, and you have 7 minus 3, which is just 4 as the answer. Now, a couple things. So remember, FOIL stands for first, which is the first in each binomial, outside, which is the two outside numbers, then inside is the two most inside numbers, and then the two last numbers from each binomial. And if you remember, these are conjugates of each other when you have the same numbers but one's plus and one's minus, and the middle terms for conjugates will always cancel when you multiply them together, and that will actually be important for what we're going to do next in this lesson. All right, so real quick, 27 here, just to show you with cube roots, you do the same thing. So when we're going to distribute here, this is going to be the cube root of 216 when you multiply those together, minus the cube root, so now I'm going to multiply these together, and then I'm going to get 270. And then we're going to see if we can break apart those cube roots. So first of all, the cube root of 216 is just 6, okay? And that is, cube root of 216 is 6 because 6 times 6 times 6 is 216. So the index, which is this number here, tells you how many times to take a number times itself, so in this case we wanted 3. Now, there's not a perfect cube root to 270. We cannot use this list of numbers we made though, because this is our square numbers. So we need a list of cubed numbers. So like 1 cubed, 2 cubed, 3 cubed, 3 cubed is not 16. 3 cubed is 27. All right, so it turns out this is the cube root of 27 and the cube root of 10. The cube root of 27 is 3, so we have 3 cube root of 10 with a minus, and then the 6. That is your answer, reduced. All right, we're going to move on to rationalizing denominators. So occasionally in math we do things because there's like a math etiquette that this is the way it's supposed to be done. And you know, these rules set a long time ago. So one of them is, it is improper to leave a radical sign, either a square root, cube root, fourth root, fifth root, whatever, in a denominator, so on the bottom of a fraction. So we have a process that's called rationalizing the denominator that will get rid of the denominator, get rid of the radical in the denominator. So a quick example here, let's say I have 1 over the square root of 2. Okay, that is some number. Plug in a calculator and get it as a decimal. I need to do something to this to get the radical off the bottom, but I can't change the number. It still has to be the same decimal. So the only thing you can do to a number and not change what the number is, you can add 0, or you can multiply by 1. And I'll change that to the x multiplying. You can multiply by 1. Well, adding 0 really kind of does nothing. So multiplying by 1, they'll be like, well, multiplying by 1 does nothing as well. It keeps the number. But 1 comes in many forms. 1 is, 3 over 3, or the square root of 5 over the square root of 5, or x over x. 1 comes to us in many forms. We just need to pick the right form that's going to cancel the square root. So the other thing that we talked about the other day is, do you happen to remember like what the square root of 2 squared is? It's 2, because the square root and the square undo each other. So really, if I have 2 of the same thing, because I could do square root of 2 and the square root of 2, that's the same as the square root of 2 squared, and then that cancels my square root. So I'm going to multiply by 1, but I'm not going to write it as this kind of 1. I'm going to write it as the square root of 2 over the square root of 2, because that is 1. That equals 1. So then how do you multiply fractions? You multiply straight across. So on the top, 1 times the square root of 2, I'm just going to write it as the square root of 2. You could write it though as 1 square root of 2. And on the bottom, this is the square root of 2 squared, which is just 2. And what we've accomplished is we've lost the radical off the bottom. So if you want to, you can put this original fraction in a calculator and get a decimal, and then put this new fraction in a calculator. You should get the same decimal. It's the same number. All we did was we rewrote it without the radical on the bottom. That's what this process is used for. So let's look at the extra practice. Now, there's a couple ways to tackle these. And for 13, what I'm really going to recommend is using your quotient property we talked about in the first video. And I want you to actually put this back together into one fraction. The reason we're going to do that is because I'm pretty sure 15 500ths reduces. And why not just reduce it first? So 15 over 500, 5 goes into both. We're going to have 3 over 100. Then we're going to use the quotient property again, and we're going to split it back apart. I cannot break down the square root of 3 at all, but the square root of 100 is just 10. And do you see how I lost the radical on the bottom? So I don't need to do anything else. I'm done. Like, that's my final answer. Okay, So let's look on at 14. So 14 is already one fraction. So when you have it as one fraction, usually the first thing you're going to do is you're going to split it apart. This one, the bottom, has a nice square root, but the top, can I simplify the top? What perfect squared number goes into 8? 4 does. So I have the square root of 4 and the square root of 2. So on the top, the square root of 4 is 2, square root of 2, and the bottom I have 100. Nope, I don't have 100. What do I have on the bottom? On the bottom I have 10. Okay, and then you're going to look at this 2 over 10, and that's going to, 2 goes into 2 once, 2 goes into 10 5 times, and your answer is the square root of 2 over 5. You are still dealing with a fraction, and you still have to deal with all of your typical fraction rules. All right, up next is 15, and there are several ways to tackle these, but the way that sometimes I really like to do it is I like to put them back together first and to do any reducing that I can reduce. So if I put these back together, and then I look to reduce. So 3 over 80 does not reduce. All right, but what about x squared over x? That x on the bottom is going to cancel with one of those x's on top, and you're just going to have that one x on the top left. And then those y cubes actually cancel. So putting it back together and canceling those leaves us without having to deal with them later. So technically what you have right now is you have the square root of 3x over 80. Then you're going to split it apart. Okay. And then we're going to see if we can reduce the square root of 80. So what of your perfect squared numbers goes into 80? 16 does, 5 times. So that is going to give us the square root of 3x over 4 square root of 5. And this is where we have to rationalize because we cannot have this square root of 5 on the bottom. But the 4 on the bottom is fine. So don't even think twice about the 4. Leave the 4 where it is. I cannot have that square root of 5 on the bottom. So we're going to multiply by 1, but our 1 is going to look like the square root of 5 over the square root of 5. So when we multiply straight across the top, we have the square root of 15x. And when we multiply the bottom, square root of 5 times square root of 5 is actually 5, because it's the square root of 5 squared. And then you're going to times it by that 4, and you're going to get a 20. And that's our answer. So we're going to skip 16 right now, and we'll deal with cubes at a later time. All right, here's our last row, and we're done. So if you'll notice this whole row, they have binomials on the bottom. That means you have 2 terms, right? A first term and a last term on the bottom. We're still going to rationalize, but this time you're going to multiply by the conjugate. I've brought this word up a couple times. The conjugate to a plus b is a minus b. So when you multiply here, and I'm going to rewrite this a little bit over to the side so I have a little bit more room. Okay, that's just the original problem times, we're going to multiply it by negative 3 plus 3 square root of 3 over negative 3 plus 3 square root of 3. So I am still multiplying by 1. This is 1. Anything over itself is 1. Okay, but my 1 is in the form of the conjugate to the denominator on the other side. So on the top, you're just going to distribute. Okay, we got a 5. Remember, a fraction bar is a grouping symbol, so this is technically grouped. So you're going to distribute your 5. So you're going to get negative 15 plus 15 square root of 3. Remember, only multiply the coefficients and then the radicands. So if there's only one radicand, it just stays. On the bottom, you're going to FOIL. So I kind of like to do it just right kind of by the problem because they're both grouped. So what do you get when you multiply first? You're going to get a positive 9. And then outside is a negative 9 square root of 3. Inside is a positive 9 square root of 3. And last is a -9 square root of 9, and we'll address that. So we've got two things here to address. The first thing is the middle two terms. Notice they are opposites of each other, and so they are going to cancel. That's because you multiplied conjugates together. I mentioned that before. And then that last term down there is really -9 times 3, which is a -27. So on the top you had -15 plus 15 square root of 3. And on the bottom we had 9 minus 27, which should be -18. And then you're going to reduce, and you're going to look at three numbers. You're going to look at this number, and this number. And if they all three reduce by the same number, you reduce all three of them. If they don't all three reduce by the same number, you don't reduce any of them. So actually -3 goes into all of these. -3 goes into -15 5 times. -3 goes into +15 and -5 times. And -3 goes into -18 6 times. And that's your answer, and you leave it just like that. All right, for room's sake, we're going to do number 19. So I'm going to rewrite the original, and then we're going to multiply it by its conjugate of the denominator, which is going to be the square root of 2 plus 5 square root of 3. Okay, on the top you're going to distribute, which is going to give you 4 square root of 2 plus 20 square root of 3. And on the bottom we're going to FOIL. So first, square root of 2 times square root of 2 is 2. Outside is 5 square root of 6. Inside is a -5 square root of 6. And last is a -25 square root of 9. Now at any time you can kind of, like, as you're multiplying conjugates, go like, hey, I know the middle terms are going to cancel. I don't actually need to write those down. And we can go ahead and make this a 3 over here if you want. So we have 2 minus 75. So on the top you have 4 square root of 2 plus 20 square root of 3 over a -73. And I don't believe anything there is going to reduce. You just leave it just like that. All right, I know we have a lot going on. Let me know if you have any questions. Okay, I'll be live to answer those later this week. Take care.